Okay, so now here we're gonna use what we know about derivatives and finding derivatives and so forth to answer this question. So it asks, find the equation of the tangent line to the curve y equals x squared plus 2 at this given point. So you want to find the equation of the tangent line, and you're given a point on that tangent line, right? This curve looks something like this, right? And the point 1, 3 is like some point right here. You want to find the equation of this line. You know a point on that line. The only thing that you're missing then is slope. And the slope of the tangent line is the derivative. So what I'm going to do is I'm going to first find the derivative of this function. I'm going to write y prime, or if I call this f of x, I'm going to find f prime of x using the definition of the derivative. And I'll write it in general. I could have done it at a particular point, the point 1, but I'll just do the function definition of a derivative. So it's the limit as h goes to 0 of f of x plus h minus f of x over h. And again, this function gives me the slope of the tangent line at any point x, including 1, which is what I'm going to want in a second. But okay, now I fill in. So now I have limit as h goes to 0 of, this is going to be x plus h squared plus 2 minus x squared minus 2. All of it over h. This becomes limit as h goes to 0. This squaring becomes x squared plus 2xh plus h squared plus 2 minus x squared minus 2 over h. And what we see here is that I'm going to have this x squared cancel with this x squared, this 2 cancel with this 2, and I'm just going to be left with the limit as h goes to 0 of 2xh plus h squared over h. I could factor out an h or cancel out the h. I'm going to be left with the limit as h goes to 0 of just 2x plus h. And this is going to tend towards 0. And I'm just going to be left with 2x. So the derivative function is just 2x here. Now, I use that fact. I say f prime of x. I have to have a geometrical interpretation of the derivative of f. The derivative of f is the slope of the tangent line at any point x. So I know the derivative is just 2x. F prime of 1 is what I'm looking for, because the point is 1 along x. So this is 1 along the x-axis. And when I plug in 1, I get the slope. The slope is 2. So now I have a point on my line, and I have the slope of my line. However you want to go about solving for the equation of the line in whatever form you want to leave it in, that's fine. I'm going to use, since I'm given slope and a point, I'm going to use point slope form. You might not be comfortable using point slope form, but if you're not, then use y equals mx plus b form, whatever. Get the equation of a line in any which way you like. This is point slope form of a line. Y minus y1. What's the point here? The point is 3. M we just solved for is 2. X minus x1 is 1. And this is sufficient. This is perfectly sufficient. This answers the question. Find the equation of the tangent line. This is the equation of the tangent line. Okay, to the curve, to this curve at this point. Okay, I could have changed it. I could have said whatever. I could have changed the point. I could have made it, I don't know, 2 comma 4 would be 6, right? So when I plug in 2 for x, I get 4. 2 squared is 4 plus 2 is 6. So I could have found it here. I could have found the slope and then used that point, and I would have gotten the equation of the tangent line for this line. Okay.